Good morning. I'm going to go over simple probability, and the reason I'm pre-recording this is so that hopefully we can get through all of the lessons that we still have for this week. That way you have all 5 of the remaining videos so that you can hopefully finish your whole unit by the end of this week. Because next week you only have 2 days of summer bridge, and then the entire pathway is due. So I'm trying to kind of give you a head start. That way in case you have to redo any of the lessons. So this week's lessons are technically simple probability and making predictions. Next week's lessons would be area of triangles, circumference, and area of circles. I'm going to go ahead and do these 2 by video. And my live lessons this week will be over area of triangles, circumference, and area of circles. Some vocabulary. Probability is the number of favorable outcomes over the number of possible outcomes. So it's kind of like flipping a coin or spinning a spinner. Impossible would be a 0% probability. It could be anything like grabbing a blue marble out of a bag that only has red and green ones, or rolling a 7 on a 6-sided dice. That's never going to happen. Unlikely is like a 1 in 6 chance, so that's rolling like a 2 on a dice. It's kind of unlikely because you have 6 total outcomes. An even chance would be a 50-50 chance, so like flipping a coin. Something that would be likely would be anywhere where your fraction of probability is closer to 1 whole, and then certain would be 1 whole. So like getting a heads or tails while flipping a coin. That's definitely going to happen. Some more vocabulary for this unit would be experimental probability is what actually happened when you did an experiment. Theoretical is what should happen based on the numbers. And then your sample space is all of your possible outcomes. For example, what is the probability of landing on a yellow on this spinner? So if we're looking only at the yellow section, it's 2 sections out of how many total sections? 8. So 2 out of 8, and then in probability, you always want to simplify your fraction. So I can divide the top by 2 and get 1. I can divide the bottom by 2 and get 4. So I have a 1/4 chance of spinning a yellow. An even number would be 2, 4, 6, or 8, which is 4 possible chances out of 8 total, and that would be 1/2. And then last, not landing on a red. So our red is only 1 spot, so not getting red would be 7 of the spots out of 8 total. So that's highly likely that you would land on a not red. All right. So if you're rolling a 6-sided die, which is a normal dice, what is the theoretical, which means probable outcome of rolling an odd number? So what are all of your possible outcomes? 1, 2, 3, 4, 5, and 6. So an odd number would be which ones? 1, 3, and 5. So that would be 3 out of 6 total, which gives you 1/2. And then rolling just a 3, how many 3s are on a dice? Just 1. So that'd be 1 out of 6. So it's not very likely that you would just roll a 3. What is the experimental probability of rolling an odd number or rolling a 3? So we have the same questions, but this time we have to use this table because this is the experiment that took place. So first we're going to figure out how many times they rolled the dice. Here's 5. 5 plus 7 is 12, plus 5 is 17, plus 6 is 23, plus 4 is 27, plus 3 is 30. So they rolled 30 total times. Okay, so an odd number would be, do a different color, the 1s, the 3s, and the 5s. So we got to add those up. We have 7 here, 6 here, which is 13, and then 3 more. So that's 16 out of 30 total, which if I simplify that, I can get 8 out of 15. So that's actually a little more than half, which is a little more than what we had predicted. And then rolling a 3, we only want to focus on the 3. That was 6 times out of 30 total. And if I simplify that, I get 1 out of 5. And if you remember on the last screen, it was 1 out of 6. So it is a little more likely just based on the experimental, but it was relatively close. And then what is the probability of getting a hit based on this experiment right here? So you have 6 at-bats. So our total is going to be 6. And how many of them did he get a hit? 1, 2. So that's 2 out of 6, which is the same as 1/3 of the times. So about a 33% chance. And then getting an out would be the opposite. So that would be 1, 2, 3, 4 out of 6, which is the same as 2/3. And so that's about 66% of the time that they get out. And if you have something like this, which is like only 2 possible outcomes, they should add up to be 1 whole, which in this case, 1/3 plus 2/3 equals 1 whole. So that's just something else to think about if you're trying to check your answer. If you put 20 marbles into a jar, so we have 20 total, 6 red, 7 blue, 3 orange, 2 pink, and 2 purple, what is the probability of choosing a red marble? Okay, so if we have 20 total marbles, how many of them are red? 6. Can 6 over 20 be simplified by 2? That would give us 3/10. So the probability of getting a red marble is 3/10. What is most likely to be pulled? So basically, which one has the highest chance of getting pulled? Well, which one has the most marbles? The 7 blue is most likely to get pulled because it has the most chances in the bag. It has the most marbles in the bag. If you are working a game booth at your school's fair, to play the game, you toss quarters onto a table that has squares and circles on it. If a quarter lands completely in a circle, the player wins $1. You start to count the number of wins and losses, and so far there are 17 wins and 123 losses. What is the experimental probability that a person will win? Okay, so if we have 123 losses and 17 wins, how many total plays is that? So we're going to do 123 plus 17, and that gives us 140 total plays. So I'm going to take the wins, because they want their chance of winning, which is 17, over the total, which is 140, and I'm going to simplify that, if it can be simplified. Does 140 divide by 17? It does not. So your chance is 17 out of 140, which is approximately 8% chance of winning. 8 and 4 out of 140. So an 8% chance of winning. All right, that concludes simple probability.